Welcome to History in a Hurry. I'm Professor Scarlett Hayes. In this episode, we will learn about the astronomer Tycho Brahe. Tycho Brahe, from 1546 to 1601, was a Danish astronomer whose precise observations of the heavens helped lay the foundation for the scientific revolution in astronomy. Though he worked before the invention of the telescope, his meticulous recordings of planetary motions provided the data that later enabled Johannes Kepler to formulate the laws of planetary motion. A colorful figure known for his noble background, artificial nose, and fiery temperament, Brahe's life was as fascinating as his contributions to science. Tycho Brahe was born on December 14, 1546, into a noble Danish family. He was originally intended for a career in law, but an eclipse of the sun in 1560 so captivated him that he turned his focus to astronomy. Recognizing his talent, his family allowed him to study at the University of Copenhagen, followed by further studies in Germany at Rostock, Wittenberg, and Basel. In 1566, while at the University of Rostock, Brahe was involved in a duel over a mathematical disagreement, which resulted in the loss of part of his nose. For the rest of his life, he wore a metal prosthetic nose, rumored to be made of silver and gold. This unusual feature contributed to his legendary persona. Brahe's first major astronomical discovery occurred in 1572, when he observed a supernova in the constellation Cassiopeia. At the time, the prevailing belief was that the heavens were unchanging and perfect, as proposed by Aristotle and Ptolemy. However, Brahe's detailed observations showed that the new star was far beyond the moon, contradicting the idea of an immutable celestial sphere. His findings, published in De Nova Stella, 1573, challenged existing astronomical beliefs and helped spark a shift away from ancient cosmology. Impressed by his work, King Frederick II of Denmark granted Brahe an island, Scheveningen, in 1576, along with funding to build a grand observatory called Uraniborg. Equipped with state-of-the-art instruments, Uraniborg became the most advanced astronomical research center in Europe at the time. Brahe designed new instruments, improved measurement techniques, and recorded planetary positions with an unprecedented degree of accuracy. His data collection would later prove crucial in understanding planetary motion. During his lifetime, the heliocentric, sun-centered model, proposed by Copernicus, was gaining attention, but it remained controversial. While Brahe rejected the idea that the Earth moved around the sun, he also recognized flaws in the geocentric, Earth-centered model. As a compromise, he proposed the Tychonic system, in which the sun orbited the Earth while the other planets orbited the sun. This model sought to preserve Earth's central position while incorporating some aspects of Copernican theory. Although ultimately incorrect, the Tychonic system was widely accepted for some time, as it provided an alternative to both traditional geocentrism and the radical heliocentric theory. Following the death of King Frederick II in 1588, Brahe lost royal support. His relationship with the new king, Christian IV, was strained, leading to the loss of his estate on Scheveningen. In 1597, Brahe left Denmark and sought patronage elsewhere. In 1599, he was invited to Prague by Holy Roman Emperor Rudolf II, who appointed him imperial mathematician. There, Brahe set up a new observatory and continued his work with the help of his assistant, Johannes Kepler. Kepler would later use Brahe's precise data to develop the laws of planetary motion, which provided critical evidence for the heliocentric model. Tycho Brahe died on October 24, 1601, under somewhat mysterious circumstances. According to historical accounts, he suffered from a bladder infection, possibly caused by his refusal to leave a banquet to relieve himself. Some later theories suggest poisoning, but no conclusive evidence supports this claim. Despite his rejection of the heliocentric model, Brahe's precise astronomical observations were his greatest legacy. His data enabled Kepler to prove that planets move in elliptical, not circular orbits, fundamentally reshaping our understanding of the cosmos. His work also helped transition astronomy from a philosophical and theological discipline into a precise observational science. Today, Brahe is remembered as a brilliant and eccentric figure whose contributions to astronomy were instrumental in the development of modern celestial mechanics. His combination of careful measurement and innovative thinking paved the way for the scientific advancements of the 17th century scientific revolution. Thanks for racing through history with us on History in a Hurry. If you enjoyed today's quick dive into the past, don't forget to like, subscribe, and hit that notification bell so you never miss a fast-paced trip through time. Please reply in the comments with ideas for our next history lesson. See you in the next one.